Researchers tell us that 10 to 35% of people suffer from long COVID following an acute COVID infection. That means millions are still struggling with long COVID, even 5 years after the pandemic started.
The parts of the brain that are affected by COVID overlap significantly with those that are affected early in the course of Alzheimer's disease. They're not identical, but they overlap significantly.
Our guest is a leading long COVID researcher, Dr. Gabriel de Erausquin, a neurologist at the University of Texas Health San Antonio. He's the first guest in our two-part series about the latest long COVID research.
I do agree with the overall gist of the publication in the sense that I think that it's not nearly as common as we thought initially it would be. And that the overwhelming majority of the cases that are reported as long COVID are indeed perhaps an extension of anxiety and depression in people who already had significant impairment prior to being infected.
This is Conversations on Healthcare.
Well, welcome, Dr. Erausquin, to Conversations on Healthcare.
It's a pleasure to be here.
That's great. You know, you've studied the effect of long COVID on cognitive impairment among more than 3,500 adults from 8 countries. Your recently published study found that older adults with long COVID had double the risk of moderate to severe cognitive impairment compared to younger patients. I wonder if you could tell our listeners about the importance of this finding and the implications.
That's an interesting place to start. The importance will depend on whether what we have found generalizes, and what I mean by that is remains true over the long term. The data we have now overwhelmingly are from 1 or 1.5 years after the original infection, and we are now long past that the timeline. And what we need to figure out, and we're doing studies currently to address that question, is whether what we found in that initial set of samples is stable, meaning it remains the same, has gotten worse, or the impairment has become progressive, or has recovered to some extent. And that is really the crucial question. Most of the indications we have from follow-up data are that it is either the same or progressive. We don't see recovery in older adults. We do see significant recovery in folks under the age of 60, but not in people over the age of 60. So what this implies is that assuming it remains true, it implies that the likelihood of developing significant cognitive impairment, which is already a public health problem, as you might know, the rates of dementia in the older adult population in the United States and worldwide, because of the aging of the population itself, have increasingly become a public health concern and are only likely to increase over the next 10 or 15 years. This would imply, if it remained true as I suggested, that the magnitude of that crisis is at least 2 times greater, if not more.
Well, I'm sure this caused you to look at the data and ask whether there were predictors that you could find of who is likely to have this dementia-like impairment in older adults, whether there was a genetic connection or comorbidities. Can you tell us a little bit about that?
Yes. We know a little bit about what predictors are related to the acute infection. And the best predictor appears to be persisting impairment in olfactory function, anosmia. That seems to correlate quite closely with the ongoing presence of cognitive impairment. Other predictors, such as, for instance, the severity of the acute disease itself, whether the person required oxygen management or even admission to an intensive care unit, are less robust. They do predict a little bit of the risk, but not as clearly.
And I want to make sure I heard you clearly. Did you say olfactory difficulty with smelling was the primary predictor?
That is what I said, yeah.
Okay, thank you. Just wanted to make sure I heard that right.
The other predictors that you mentioned, genetics, are precisely what we're looking into now. We are carrying out a longitudinal study that will be completed in 3.5 years from now or so, in samples in 3 countries, in the United States at 5 different sites, in Argentina and in Nigeria, addressing precisely that question and focusing on those populations or those segments of the population that were most severely affected by the disease itself, by COVID itself, both in terms of morbidity and in terms of mortality. In the United States, as you will remember, the locations that were the hot spots of the pandemic were the 2 coasts, so Seattle and New York particularly. And the populations that were most affected were Native Americans and Hispanics, followed somewhat behind by African Americans, and the least affected population were Caucasians or whites. The study focuses on those populations, so we will focus on both. We have a sample in Seattle, a sample in New York, 2 samples at the border, San Antonio and Laredo, and then, as I mentioned, Nigeria and a site in northwestern Argentina. It's also Amerindian, overwhelmingly the population, because those are the populations most affected. The rationale is that, as you were suggesting earlier, there may be a genetic predisposition for the long-term cognitive impairment that follows the disease. And the early data suggests that indeed we are on the right track. Mm-hmm. We found that about 50%, depending on the margins of the estimates, between 40 and 60% of the risk of developing cognitive impairment after COVID was indeed inherited. What genes are affected is the part of the study that remains to be done. We are looking at very detailed genetic descriptions, so what's called whole genome sequencing, to address that question.
You reported that for long COVID patients over the age of 57, the symptoms associated with cognitive difficulties look much like early dementia. I'm wondering if you could share more with us about that finding.
Sure. Actually, the term dementia-like was coined earlier than us by a publication in late 21 or early 22, I can't recall right now exactly the date, looking at the UK Biobank sample. This is a population-based sample of the United Kingdom that has fairly detailed data, including brain imaging on an ongoing basis. When they looked at the consequences of COVID in that sample, they found a segment of folks that had what they call dementia-like symptoms. We used the same turn of phrase to describe the findings in our international samples for simplicity's sake. But what that means is that these people have primarily difficulties with recall of very recent information, what people tend to call short-term memory, meaning, conversations that we had in the past 24 hours or very recent events, what tend to be called episodic memory. So the substance of what may have happened when I went to dinner last week. that type of memory loss is the earliest affected in Alzheimer's disease, and it also seems to be the earliest and most prominently affected in long-term COVID. The second type of impairment is also common, frequent problem that we all have after the age of 50, but becomes much more prominent in early Alzheimer's disease, and that is we tend not to recall a word that we want to use in conversation. Or in the normal case, we typically recall the word a few moments later after we had it at the tip of the tongue for a little while. In the case of Alzheimer's disease, the word tends not to come back. Mm-hmm. And in the case of these folks with long-term COVID, the loss looks more like it does in Alzheimer's. This extends to names of acquaintances or friends, or in more severe cases, family. Mm-hmm. This naming impairment is actually quite common, and that is seen as well. Mm-hmm. The third type of cognitive difficulty that these folks experience is with what's typically called executive function, meaning the common ability to sequence and prioritize and do hierarchical organization of tasks, for instance, carrying out a recipe or making a small repair or using the remote control of the television set and things of that sort that require a little bit of organization and correct sequencing in order for them to be effective. That tends to be lost early in Alzheimer's disease, although it's usually after the loss of the memory function. And the same happens in this group of people. Now, what we have called, or what has been called by the UK Biobank people, dementia-like symptoms, is the presence of all three of those types of deficits simultaneously in the same person to a significant degree, significant statistically speaking, so more than 1.5 standard deviations away from the average for that sample.
Maybe I could ask you, because I think some of this is probably new to our listeners, to differentiate, since you're noting that this is more likely in older persons than younger persons. Younger persons with long COVID seem to recover the cognitive function, but older people are at risk for the dementia symptoms or conditions just by virtue of age. How do you sort the two out? And of course, what people would want to hear is, what's the best advice for treatment?
We didn't sort it out. It was empirical. What we did is we looked at the population as a whole, and in statistical terms, we look at what's called the distribution of a particular phenomenon, meaning the frequency with which that particular phenomenon occurs in a sample for a particular population. Everybody is familiar with the notion of the bell curve. The bell curve is the typical, what's called normal distribution of a phenomenon in a population sample, meaning that you have an average that is the most common value for that particular feature, say height, 5 feet 11 or 5 feet 10. And then you have tails both ways, a tail that moves towards lower heights and a tail that moves towards taller heights. And you have extremes of that distribution that are typically what's called 2 standard deviations or 3 standard deviations away from that mean, that value in the center. Now, when we looked at the distribution of this data, it looked not like a single bell, but rather like a camelback, meaning that it had 2 separate peaks at different ages. And that is characteristic of what's called a bimodal distribution sometimes, but it's characteristic of a phenomenon that splits a population into different groups that tend to be statistically distinct. Now, when we looked at the distribution of the cognitive impairment in these large samples or these 3,000 people or so from throughout the world, we found that indeed the distribution of the cognitive impairment was very different from different age groups.
I see.
And that's where the conclusion comes from. So it was an empirical finding. It was not something that we were looking for necessarily, although we had some hints from previous data that might be the case.
Well, you
Sure, go ahead, sir.
Well, you conducted some earlier studies that found that COVID infection led to elevated neurodegenerative biomarkers and inflammation in the brain. And this occurred even among people without a history of neurodegenerative disease. Tell us what you think that suggests.
That actually is the strongest bit of data. I was focusing mostly on the international study, because that's the one you pointed me to in the beginning. But as you point out, we have in some of these samples, some other samples from other groups, for instance, the sample in New York City from Langone School of Medicine, that the group has been led by Dr. Wojciechowski. That group and ours have found very similar things. And as I mentioned, the UK Biobank has also similar data. Let me walk you through what are those findings. The first thing is that these folks that have more severe cognitive impairment or difficulties tend to have changes in brain structure, meaning the volume of particular parts of the brain that correlate with that memory or language impairment. The parts of the brain that are affected by COVID overlap significantly with those that are affected early in the course of Alzheimer's disease. They're not identical, but they overlap significantly. Similarly, you pointed out to biomarkers. Folks refer to biomarkers when they're talking about the presence of abnormal proteins in bodily fluid, typically. There are other ways to look at it, but usually what we look at is abnormal amounts of proteins, either in the spinal fluid, which, as you know, is the liquid that bathes the brain, or in the blood. When either the group in New York or a group in Greece looked at this, they have found consistently that after COVID, particularly in the immediate acute phase after COVID, the biomarkers of neurodegeneration that are common in Alzheimer's disease were also abnormal in this population. We have not looked at that in our sample yet. We have the data, but we're pending the results. But overall, the conclusion is that there is a significant overlap in the clinical manifestations, in the brain changes, and in the bodily fluid biomarkers between the changes that we see in an older adult population after COVID and the changes that you see, or actually, I should generalize a bit more, in the cognitively impaired population after COVID, because the New York sample didn't distinguish by age. And what you see in early Alzheimer's disease. There are more than one possible explanation for this.
I wonder if you could, again, for our audience as a whole, can you just back up a little bit and maybe talk about what is the pathway connection about loss or change in smell and taste that we see with early dementia and that you're seeing with long COVID? Maybe just for our audience.
Of course. Loss of smell is actually a very early manifestation of a number of diseases, not just Alzheimer's. It's very common in Parkinson's disease. It's rather common in frontotemporal dementia. And it's actually exceedingly common in Alzheimer's disease. The reason this occurs in Alzheimer's disease, anyway, is that early memory or short-term memory related structures overlap with what is called the extended olfactory network. This is actually the part of the brain that processes olfactory or smell related information after the initial sensation of smell is detected. Much like when you look at the parts of the brain that compute visual information, the light that is shown in the eyes initially affects the activity of the so-called primary visual cortex in the occipital lobe. But then from there, it bounds, if you will, or goes to other parts of the brain that are responsible for more complex processing of that light signal. The same happens with smell. You have an initial detection of the sensation of smell and a discrimination of what that smell might be, that in the temporal lobe that then goes to other places. And so those other places, the extended olfactory network in the brain, are affected early by Alzheimer's disease and also by long-term sequelae of COVID.
You know, Doctor, you have a follow-up study involving about 4,000 people in 5 locations around the world. These are patients who contracted COVID when they were over 60 years of age. Wondering what the preliminary data is showing. Also wondering, are these individuals who were treated with Paxlovid, or how are you separating out that group, or does that matter in your study?
So these are folks that were affected by the first wave of the pandemic, meaning they were contracting the infection between 2020 and 2021. We are interested in particular in the variants of the virus up to Omicron, because those are the ones that appear to have had the strongest impact on the central nervous system function. So that is the preliminary study I was pointing to when I was referring to our data in Seattle, New York, Texas, and Nigeria and Argentina. Regarding the question of treatment, we are agnostic to the treatment that they may have received, because during the first year of the pandemic, no treatments were available, not even vaccines were available for the first 6 or 7 months. So we are collecting that data, but we have not looked at it yet. We don't know with any detail if for instance, if the variants of the virus have a definitive impact on how likely you are to develop any of the symptoms. The initial impression is that up to Omicron, all of the initial variants had roughly equal likelihood of causing this cognitive impairment, but we need to look at that in more detail. Like vaccines had an interesting impact, though. In the early analysis, we did a preliminary analysis of 500 cases or so, and a bit against my expectations, I have to admit. I thought vaccines were not going to be relevant for this particular long-term sequela, but it turns out that they are. People who acquire the infection before being vaccinated, and this is regardless of vaccine type, we had too much variability in the types of vaccines that people were receiving to be able to make any sense out of it. But it seems like people who were vaccinated before being exposed to COVID had a lower risk of developing cognitive impairment than those that were vaccinated after having COVID. That is very preliminary data from only about 500 patients. But if that were to be true, that would be perhaps one of the very first definitive positive effects that the vaccines have had. Because otherwise, as you probably know, they did not reduce the risk of infection, and it's very unclear whether they reduced the risk of severe disease. Yeah. But they appear to have reduced the risk of long-term sequelae, and that would be a really good thing.
That would be very important to know, especially we live in such a time of science skepticism. There are still those who doubt, I think, everything about COVID, the treatment, the severity, and whether long COVID is real. And I think a British medical journal analysis reported that major flaws in the current body of published research on long COVID have greatly exaggerated the true risks of developing the condition. That's a very global kind of statement when we look across the age range, being from children to our elders. What was your reaction to that piece of work?
I have to admit that I'm somewhat sympathetic to that finding, and in the sense that what we know about the long COVID in younger adults strongly suggests that at least a number of those cases were people who had significant impairment before having COVID. The biggest predictors of the younger adult version of long COVID are pre-existing anxiety and depression, symptoms of chronic pain such as fibromyalgia, diagnosis or chronic fatigue syndrome. And in fact, the clinical manifestations of long COVID seem to overlap with chronic fatigue or fibromyalgia to a significant extent. That doesn't mean that, in my mind, long COVID does not occur in those patients. In fact, I treat a significant number of those patients, and I'm convinced that when you look carefully enough at the biomarkers of inflammation, they are present. The disease is distinct. In other words, it's not just fibromyalgia or just chronic fatigue. There are specific changes in their blood biomarkers, and they tend to have two particularly notable symptoms. One of them is physical impairment, meaning fatigability, which is similar to chronic fatigue, but it's manifested more apparently with the presence of, for instance, the incapacity or the inability to walk for any length of distance without having to rest, and significant respiratory impairment that often forces them to wear oxygen when they walk about. So these two manifestations are actually, I won't say unique, but rather specific to young adult long COVID. I do agree with the overall gist of the publication, in the sense that I think that it's not nearly as common as we thought initially it would be, and that the overwhelming majority of the cases that are reported as long COVID are indeed perhaps an extension of anxiety and depression in people who already had significant impairment prior to being infected. I see a fair number of those as well.
Doctor, I think, I can just get in one last question here. I know
before you do, let me just say that doesn't apply to the dementia-like symptoms. The dementia-like symptoms are absolutely solid in their presence when they are present, and they are not accounted for by pre-existing disease. We made a point of excluding those very carefully. What we don't know, and that this is hugely important, is whether what the disease did was to accelerate a pathological process that was going to happen anyway. In other words, these are folks that were going to develop Alzheimer's at a later point in life, and what COVID did was to
accelerate it,
precipitate it, make it happen sooner.
Yeah,
and that we don't know.
You know, the work that you're doing.
Go ahead.
The work you're doing is so important, and you mentioned NYU Langone, and while so many people would like this to be in the rearview mirror, there's important research work that needs to be done. If you look at the lay of the land, how is the support and funding out there for this type of research? What are the obstacles you're facing? I think this is an important issue because it's such a complex and perplexing problem that obviously needs science to take a hard look at it.
You would think that would be an easy target for the NIH review. Thank God, and I have not an inside information that may allow me to tell you why we have not been affected by any of those reviews so far.
We're glad to hear that.
Yeah, there are two, as you probably know, two lines of investigations or research that have been primarily targeted by the review. The first one was what they consider, the government considered to be related to DEI. In other words, the minority targeted research or underserved populations research and such. In that round, for reasons that escape me, because we are targeting the population that was most affected by COVID, that is by definition minoritized, we were not affected. In other words, we were not told that we're at risk of being reduced or canceled.
Good.
The second round of, which is very recent, actually happened last Friday, reviews and the second pause in funding is for international funding, which again should affect us quite dramatically because the largest part of what we do is international. But my reading of the decision, the note, is that it will not affect us, at least for this year. I have not heard definitively from our program officer at the National Institute of Aging whether that's the case or not, but just reading the note, it seems that we are not under the categories of research that they are going to pause.
Wonderful.
Wonderful. Well, we're happy for you on that. It's important work, and we want to thank you, Dr. de Erausquin, for joining us today for this important conversation. For those who want to learn more, look for part 2 of our long COVID series. And thank you to our audience for being here. Just a reminder, be sure to subscribe to our videos on YouTube, find us on Facebook and X, and please share your thoughts and your comments about this program. Take care and be well. This copyrighted program is produced by Conversations on Healthcare and cannot be reproduced or retransmitted in whole or in part without the express written consent from Community Health Center, Inc. The views expressed by guests are their own, and they do not necessarily reflect the opinion of Conversations on Healthcare or its affiliated entities.